This video will cover the skeleton program for 2024. The program uses a range of custom classes, 4 to be exact. There is one main class that does most of the work, and 3 other classes used for storing data efficiently in objects, one of which uses inheritance and overrides a parent's functionality. You'll learn more about so shortly. We'll start with the easy classes, the cell and blocked cell classes. As you'll come to see, blocked cell is a child of cell, and this is the class I mentioned earlier when talking about overriding parent functionality. Before we start looking at the cell class, let's have a recap of the general structure of a class. In the classes you'll see in this program, there are 3 distinct properties that they all share. They are the constructor, fields, and subprograms or functions, which we'll just call methods. The fields can be imagined as global variables that can usually only be accessed within the scope of that class, meaning that you'll need a reference to that class to access that field. You may have also spotted this private keyword. This is called an access modifier, and this program uses 3 different types of them: public, private, and protected. We'll save protected for later, but here's what public and private does. Public means that you can access that field method with an object reference like seen on screen. Private means that you can only access that field method only inside that class and nowhere else, not even inside any children classes. A constructor is a special piece of code that runs when you instantiate a class. This is where we do a lot of setups for a class before we begin to use it. As soon as the following line will be executed, the constructor will also run. It's not important to know what exactly this code does, but what you do need to know is that this code creates an object reference to that class, where our object is the variable to the left-hand side of the assignment. You can also see here that you can pass variables into instantiating a new class, and those variables are picked up by the constructor. You can have multiple constructors in a class provided they have different parameters, as you'll see with the puzzle class. Finally, we have methods. These are accessed via our object reference. They function identically to the subprograms or functions you've learned about. Here is what the cell class looks like. Here is the constructor. We don't pass anything into the constructor, but we do set up some variables so that they can be used later. We have 2 fields. One is private and another is protected. Protected is the same as private, so other places can't access it, but it has one exception. Children of this class can access it. This will be important for when we look at the blocked cell class. This class has 6 methods, one of which being unused. Expect this method to come up in a question in the exam. All these methods are very simple, so I won't go through them. Instead, we'll move on to blocked cell. Blocked cell inherits cell, seen in this line. What does that mean? It means everything cell has, blocked cell has too. Let's look at this constructor. mybase.new is likely a piece of code you've never seen before, but all it does is runs the parent's constructor, mybase being the class you're inheriting from, and the .new being the constructor for that parent. This way we don't need to repeat the code inside cell's constructor to set up the blocked cell class. We do have one small addition though. We now set the symbol to an @ symbol. We also override the parent's check symbol allowed function to always return false. This means we've created a cell that is always an @ symbol, and that no matter what symbol we give it, it'll never allow the symbol to be changed. This is a blocked cell. The pattern class is also another simple class. We have 2 fields, a constructor and 2 methods. Let's go over the fields first. If you recall, in this game we need to make symbols out of letters using their respective letters. So we use T's to make a T in a 3x3 grid or an X in a 3x3 grid. The way the game keeps track of these patterns is with the pattern class. The symbol field holds the character we are using to make the symbol, and the pattern sequence field holds a string sequence for the pattern like seen on screen. You'd think this pattern goes left to right, but this is wrong. Here is the sequence for T. If we follow our previous rule, we see it's all wrong. The pattern actually goes in a spiral, beginning from the top left and ending in the middle. Here we have T, 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 nothing, nothing, T, nothing, nothing, T. Our constructor here is quite simple. We just grab the incoming symbol and pattern string and assign them to the symbol and pattern sequence fields. Let's look at matches pattern. We take in a symbol and a string pattern as parameters. If the incoming symbol doesn't match the class's symbol, we immediately return false. If it does, we continue. The next loop will go through the incoming string and pattern sequence field character by character. This next if statement checks 2 things. If the current character the pattern sequence field is on is the same as the symbol, and if the pattern string character at that location doesn't match the symbol. If both these conditions are true, we return false and say that the patterns don't match. This code is a bit complex, so to better understand this code, let's run through it with two different inputs. We'll assume that the symbol is T and the pattern is TTT, nothing nothing T, nothing nothing T. If we have local inputs that mimics those, we can get past the first if statement. Then we go through the string character by character. T is equal to the symbol field T, so this is true. T here equals symbol, so this is false. True and false makes false, so we don't run the if statement. We do this another 2 times. Here we can see that the dash does not equal the symbol field, so we set this condition as false. On the right hand side condition, we can see that asterisk doesn't equal to symbol, so we set this as true. False and true makes false, so we don't run the if block. This will continue for the rest of the string until we run the return true command. Let's look at an invalid input of the symbol T like the one above. The first 2 times we run this, we will get false. On the third character, we will get true, and then we run the if block and return false. What observant viewers might have noticed is that, essentially, the left-hand condition checks if the character in the pattern we are checking against is on the symbol that is relevant in making that pattern. If it isn't, then this if statement's condition is false no matter what the second condition is. In this way, we can make sure that we don't compare an asterisk against a character and incorrectly return false. The right-hand condition checks whether the character we are checking for is also a relevant symbol. If pattern string count is the correct symbol, this if statement's condition will be false, meaning the return false will run. Only if we are on a valid character on the left-hand side and the right-hand side isn't on one, do we return true on the if statement's condition and return false to the caller. Finally, we are on the puzzle class, the main class that ties all the other classes together. The puzzle class has 2 constructors, one for loading a puzzle via a file name and one for randomly generating a puzzle. The puzzle class has 6 fields. The first 3 fields are self-explanatory. The next 3 are a bit trickier. Grid is a list of cells. If you remember, a cell object has 2 fields, symbol and symbol not allowed. Symbol dictates what symbol is already in that cell. Symbol not allowed dictates what symbols cannot be placed in that cell. A list of cells allows us to construct a grid. Allowed patterns is a list of pattern objects. Each pattern object contains a symbol and its corresponding pattern sequence. Allowed symbols is a string list of all the symbols you are allowed to place. As mentioned before, we have 2 constructors. One is for passing a file name and another is for randomly generating a puzzle grid. We'll start with the file name one. First, we initialize all the lists in our class so that they are ready to use. Then we run load puzzle. Load puzzle is quite a long piece of code, but it is relatively simple. Before we look at load puzzle, let's understand the structure of each puzzle file. Here is puzzle1.txt. The first line tells us how many symbols we have in our puzzle, and the next n lines are the symbols we add. The next part of the puzzle does the same thing, but with the puzzle sequences. The next line is the grid size of the puzzle. If we call this variable x, the next x times x lines will be the grid setup. In this case, that's the next 25 lines. Finally, the second last line is the initial score we begin with, and the last line is the turns left we begin with. Now we can finally go through the code. First, we load the file with our stream reader. If it fails, we run the catch block and notify the user the puzzle could not be loaded. If we have loaded a file into the stream reader correctly, we grab the first line and assign it to a variable called number of symbols. If you remember, this line tells us how many symbols are legal to place on the grid. The next line adds all the symbols. The same process repeats for the pattern sequences. However, we split the string at the comma and assign the first element to the symbol field in a pattern object and the second element to the pattern sequence field in a pattern object. We add that pattern object to the list of pattern objects we have called allowed patterns. The next part of the code builds and populates the grid. We grab the grid size and run a loop for 1 to grid size squared. We read the next line, which will be in the form of x, x, where x is a symbol, and split it at the comma to have 2 elements. The first element is the element already placed inside the cell, and the next one is the element you're not allowed to place in that cell. We check if the first element, the already placed one, is an @ symbol or not. If so, we assign C to be initialized as a blocked cell. How come a variable of type cell can be initialized as class type blocked cell? This is because blocked cell inherits cell, and therefore is a child of cell. We call this polymorphism. If the symbol is not an @ symbol, we initialize cell as a cell class. We use the change symbol in cell method to assign that cell object's symbol field to the symbol we pass in. The next line adds symbols that are not allowed to be placed in that cell. If the line has 1 or more commas in it, the first item would be the symbol already placed in the cell, and the next items would be symbols now allowed to be placed in that cell. The pattern files don't utilize more than one blocked symbol, but they can. You just need to add another comma and the symbol. At the end, we add the cell to our list of cells called the grid. We repeat this process until we add all the cells we need to. The next line we read is the initial score. The one after that is the number of symbols we have left to place. We have now finished loading in the puzzle from a file. Let's now look at the non-filename constructor. Instead of passing in the file name, we pass in the size of the grid we want to generate and the number of symbols we want to have when we start the game. The first 4 lines initialize some fields in the puzzle class. The next code block, the for loop, generates grid size squared cells. If grid size was 5, we'd generate 25 cells. When generating a cell, there is a 10% chance it'll be a blocked cell. After this, the next 2 lines initialize the allowed patterns and allowed symbol fields so that they can be used. The next 9 lines just add the patterns and symbols. It does this by first creating a pattern object and passing in the symbol and pattern sequence. It then adds the pattern object to the allowed patterns field, which is a list of pattern class. After that, it adds the pattern symbol to the allowed symbols field, which is a list of strings. The next important method to look over is attempt puzzle, but before we can look over it, we need to go through get cell, check for match with pattern, and display puzzle. We'll start with get cell. This is a deceptively hard method to understand, so we'll break it up into multiple steps. First, it's important to remember our grid is not a 2D array, but a list of elements. This algorithm first finds the number of rows above the selected row, then multiplies it by the grid size to get the number of cells within the rows above your selected row, then adds onto this count the column count. Let's go through an example in a 5x5 grid. Imagine we want to grab cells 3, 2. First, we perform grid size row. 5 minus 3 gives 2. That's how many rows we have above our target. Then we multiply it by our grid size to get the number of cells above our target's row. 2 multiplied by 5 is 10. Now we add on our column count. 10 plus 2 is 12. However, we are not quite there. Elements in a list start from 0, so we need to take away 1 from the result to get the index for the target cell. Next, let's go over display puzzle. This is the code responsible for displaying the puzzle on screen. The first block of code prints the top numbers in ascending order provided they are less than 10. After that, we print a horizontal line. A function called createHorizontalLine calculates how long the line needs to be and returns the result. After that, we run a for loop print all the rows. This for loop runs once for every cell in our grid. The first if statement block prints the row number and a space after it. We run this code once every multiple of grid size. In a 5x5 grid, we'd run this when count is 0, 5, 10, 15, 20, or 25. The print itself is also a bit complex. Consider the following table I created. Count plus 1 divided by grid size will give us what multiple of grid size count is on. So at iteration 6, count plus 1 divided by grid size will be 6 divided by 5, which is 1.2. However, as an integer, it would be just 1. At iteration 11, count plus 1 divided by grid size will be 11 divided by 5, which is 2.2. As an integer, this would be just 2. The number we have gotten tells us what multiple of grid size count is on. If we perform grid size minus the number we have gotten, we will get what column we are on. If you are still confused, please familiarize yourself with the above table. The next line of code just adds a pipe and the symbol to print from the grid. This final if statement block will run when we have finished printing the row and need to move on to the second row. We print an ending pipe and then a horizontal line. The reason we use count plus 1 here instead of just count is because we want this to run one iteration early to the column number printer. We continue this process until we run once for every cell. By the end, we should have our full grid printed in the terminal. The check for match with pattern method is the method responsible for checking for a matching pattern sequence. When you enter a row and column to check, the program will check all rows and columns between the entered row and the row and column -2. That means it will run the pattern check 9 times. Before you continue watching, please make sure you've seen the pattern class section of the video. Knowing how a pattern sequence is made and read is very important. The 2 for loops will return row and column numbers in the manner shown above. At each cell, these 9 lines of code create a pattern string. This code here checks if the pattern sequence we created matches with any of the allowed patterns we have in the puzzle. If it does, then our program knows we have completed a pattern. We can now run the inside code of the if block. At each cell inside the 3x3 where the pattern is, we add to the cell's not allowed symbol list the symbol we just completed the pattern with. At the end we return 10. This is the score given for completing a pattern. This also stops the code from searching for any more patterns. If the pattern sequence we created doesn't match with any of the puzzle's allowed patterns, we don't run this if block. There is one small issue with this system that is likely to come up in the exam. Let's take the X pattern and symbol for example. There are 4 spaces here where there is no symbol. However, when the code for finding a match runs, it'll set those 4 spaces to not be able to accept X. This may be an issue with the code, or it may be an intended feature. Either way, it would be wise to keep this in mind when doing the exam. We can move into attempt puzzle. This is the binding agent that brings together all the methods we discussed before. This finished boolean acts as a flag that keeps the game running until a win or lose condition is met. At the beginning of this loop, we display the puzzle to the user and show the user's current score. These next 10 lines ask the user for an input for the row variable. The while loop ensures that the input the user has entered is valid, and the input is only valid if the user enters an integer. If they don't, the empty catch block will run, which will restart the while loop. It is important to note that the user can enter negative numbers into row and column. This may be related to an exam question. The next 10 lines are the same, but for the column variable. The exam may ask you to create a function to house this repeated logic. After we grab the row and column, we ask the user for a symbol and decrease the symbol's left counter by 1. Using the gathered information, we grab the cell the user's row and column points to and check if the user's symbol can be placed in that cell. If so, we change that cell's symbol to the one the user entered. Then we use the method discussed before to check if there is a pattern match. If there is, the user will be awarded 10 points. Otherwise, he will be given none. There are 2 important notes to take away from this process. The first is that if a user tries to enter a symbol that is inside the symbols not allowed list, it won't place the symbol on the grid, but will still deduct 1 from the symbol's left counter. The second important note is that the user is allowed to place the same symbol in the same position twice. This means that the user will be deducted a move from the symbol left counter also. Finally, we check the user's symbol left counter. If it is equal to 0, we set the finished flag to true and end the gameplay cycle. We also display the grid for the final time and return the score achieved to the sender inside main. If symbol is not equal to 0, we restart the loop and continue the game. With all these pieces, we can discuss the final method inside the code. First, we initialize 2 string variables. One of them acts as a flag to allow the user to play the game multiple times in a row. The first thing we do is ask the user for the puzzle file they want to load. If we leave the input here empty, we use the noFileName constructor of the puzzle class to generate an 8x8 grid and give the user 38 moves. This number is 60% of all the squares on the grid. If the input isn't empty, we send that input to the filename constructor of the puzzle class so that it can load the puzzle. After this process, we run attempt puzzle and store the score inside the score variable. After the puzzle is complete, we show the user their score and ask them if they want to play again. Thanks for watching this video. Good luck on your exam.